Hi, everybody. In this video, we're going to do some trigonometry review. We're going to look at the unit circle. We're going to look at evaluating trig functions at different values around the unit circle. So to get started, first, let's make sure we can generate the unit circle. The word unit means one, which basically means that the distance from here to here, right, the radius of the circle is going to be one. And if that's the case, we can immediately get the coordinates of the points on each of the axes. So this will be 1, 0. This will be 0, 1, -1, 0, and 0, -1. From there, we're going to notice that we have two different special triangles happening over and over again in this circle. And the first one I want to look at is this one right here, which is a 45, 45, 90 triangle. This is a 45-degree angle. And we have a hypotenuse of 1, again, because that's the radius of our unit circle. So if we remember something about 45, 45, 90 triangles, they have a ratio of their sides. The ratio of their sides are A, and A root 2. And this can be shown using the Pythagorean theorem, but we won't take the time to do that right now. So with the 45, 45, 90 that we have on the circle, we're given the hypotenuse, which is 1. So 1 equals A square root of 2. If we divide both sides by root 2, we end up with A equaling 1 over the square root of 2. And of course, we can rationalize this. We can multiply by root 2 on the bottom and root 2 on top. And we end up with A equaling root 2 over 2. And so that's what we end up with here, root 2 over 2, and here, root 2 over 2. So when we go back to the circle, we have this length in the x direction is root 2 over 2, and the vertical length in the y direction, root 2 over 2. And so if that's the case, we know that this point here has coordinates root 2 over 2 for the x and root 2 over 2 for the y. Like that. So there we go with 45 degrees, and we'll switch over to 30 and 60 next. So this angle right here, we have at 45 degrees. This triangle is a 30, 60, 90 triangle. So we have 30 degrees right there. And if we remember something about the 30, 60, 90 triangle, we also have a ratio for the three sides. Again, I'm not going to go into the details on it, but basically, we have a 30, 60, 90. This is A opposite the 30, A root 3 opposite the 60, and 2A opposite the 90. Again, we know that the hypotenuse is 1. So this value right here, 2A is equal to 1. That means A equals to 1 over 2 when we divide both sides. So this guy is 1 over 2. And then if we multiply that by root 3, right, multiply both sides here and here by root 3, we'll get this value, which is going to be root 3 over 2. And so back on the circle now, we have a length along the x-axis of root 3 over 2. Here we have a length of a half. And so now we know that the coordinates of this point here are going to be root 3 over 2 and a half. So there we have our 30 and our 45. Now, going to this triangle here, this is a 60-degree angle. It ends up being the same triangle, but now we have the half down here because that's opposite the 30 degrees way up there, whereas this is the 60-degree angle over here. And we have the root 3 over 2 here. So we end up with a half for the x and a root 3 over 2 for the y. And just like that, we have come up with the coordinates of the important points for us on the unit circle in quadrant 1. Here we have a 0-degree angle, And of course, here we have 90 degrees. So before we kind of move on from there, let's go ahead and talk a little bit about radians, because if we're going to be working with trigonometry and calculus, we normally deal with radians as opposed to degrees. So let's talk circumference for a moment. You know that circumference has a formula, 2 pi r, right? 2 pi times the radius. And in this particular circle, since the radius is 1, we're going to get circumference equals 2 pi times 1, which is just 2 pi. Now, without going too much into it, radian measure, for example, this little angle here, when we have the unit circle, well, here, let's do it this way. An angle theta in radians is equal to the arc length over the radius. Basically, we're counting how many radii live in this arc length on the circle. In other words, how much of this lives in there, okay? And so if we took a piece of string and we measured this, then we took that same piece of string and aligned it on the circle, maybe it would go 1 there, and then 2 here, and then 3 maybe about there. It's not exact by any means, but that's the idea, right? We're counting how many lengths of the radius are along the curve there, right? And then that angle, right? So the angle out to here would be 3 radians because there are 3 radii along the curve, okay? Now, that means all we really need to do to find radians is take the arc length and divide it by the radius. But as we know, we have the unit circle here, so the radius is 1. So theta in radians is simply equal to the arc length of the circle, or the part of the circle that the angle opens up to, okay? In other words, we know the arc length for the whole thing is 2 pi, okay? So that's theta in radians for all the way around. Now, we also know that all the way around in degrees is 360. So if I put 360 here, I know that 360 degrees is all the way around the circle, and so is 2 pi radians. We don't need to write the RAD here. If you just write 2 pi for an angle, I'll know you mean radians. That said, we can now treat this as an equation. We could divide both sides by 2. 360 divided by 2 gives us 180. 2 pi divided by 2 just gives us pi. And so what that shows us is that 180 degrees, which is over here, is the same as pi radians. If I divide this by 2 again, I'm going to get 90 degrees is equal to pi over 2. So here I've got pi over 2 radians. And if I multiply both of these by a half, like this, I get 45 degrees is equal to pi over 4. So that means I know this is pi over 4 radians. We could go back to that 90, and instead of dividing by 2, we could divide by 3 or multiply by a third. That'll give us 30 degrees is equal to pi over 6. So now we are at pi over 6 here. And once we have that, we can just start counting in terms of pi over 6 or pi over 4. I'll show you what I mean. Basically, we've got pi over 6, then we have 2 pi's over 6, then we have 3 pi's over 6, and we can go all the way around the circle this way. 4 pi over 6, 5 pi over 6, 6 pi over 6. And what we're doing here is we're saying here's 1 pi over 6, here's 2 pi's over 6. Let's do a couple more. Here's 3 pi's over 6. So if we just look at those first three, I think we find that this guy reduces to pi over 3, and this guy reduces to pi over 2. Okay, so the blue angle is going to pi over 3, and of course the green one goes to pi over 2, which we already knew. And then if we go to 4 pi's over 6, that takes us to here. But you know that 4 pi over 6 will reduce down to 2 pi over 3. So that's what we have right here, which is at 120 degrees. And then we'll go another pi over 6, which takes us to maybe there. Not maybe, it does, which is 5 pi over 6. Which is 150 degrees. That's a 6 there. And then, of course, we get to 6 pi over 6, which is simply pi. And so there are all the radian value, well, not all of them, actually. Forgot one, and I'll talk about that in a moment. But most of the radian values in the first two quadrants. So here's quadrant 2. So the one we're missing is 135 degrees. I wonder if I can squeeze that in there, 135 degrees. And that's a matter of counting pi's over 4. So here I have 1 pi over 4. Here I have 2 pi's over 4. And here I'll have 3 pi's over 4. So 3 pi over 4. Now, from there, we just need to work the way the rest of the way around the circle. So I'm going to continue adding pi's over 6 for all the angles that have 30 degrees as their reference angles. So we have 5 pi over 6, 6 pi over 6. This will be 7 pi over 6 at 210 degrees. 8 pi over 6 reduces down to 4 pi over 3, and that's at 240 degrees. Here we have 270 degrees. That's 3 pi over 2. It's really 9 pi over 6 that got reduced. Here we have 300 degrees, which is 5 pi over 3. And then here we have 330 degrees, which is 11 pi over 6. And then here we're at 0 radians or 2 pi radians for all the way around. Now, filling in the 45s, right? So we had 45, 135 was, sorry, 40, here, let's do that right. We had 45 to there, then we had 90, then we had 135, and then we had 180, and the next one will take us to 225. And that will be 5 pi over 4. Hopefully that's not too sloppy. I'll show you a prettier one in a little bit. And then we have our 6 pi over 4, and then over here we have 7 pi over 4, which is 315. 7 pi over 4. Now, I know I did that quickly. This is review. If it's something you need help with, come and see me in office hours. We can talk about it. It comes with practice. It comes with looking at this a lot and just kind of getting used to seeing where the angles are. Of course, we have quadrant 3 down here and quadrant 4 right there. Now, I'm going to complete all of the values of the points now simply by looking at the symmetry. In other words, I'm going to look at this point here and realize that it mirrors this point with the exact same x and y values, except for x has to be negative. So this will be negative 1/2 root 3 over 2. And then the same thing is going to happen from here to here, all right? We're going to get negative root 2 over 2 and root 2 over 2. And then we'll continue on negative root 3 over 2 and positive 1/2. And so there's quadrant 2 completely finished. Quadrant 3, we get to do the same thing. Here I'm going to notice that I can take this guy and get the exact same thing there, but both x and y are negative in quadrant 3. So negative root 3 over 2, negative 1/2. Doing the same thing with negative root 2 over 2, negative root 2 over 2. and then -1/2 negative root 3 over 2. And then finally, we have the same thing going on in quadrant 4, right? So we have root 3 over 2, -1/2, root 2 over 2, negative root 2 over 2, and finally 1/2 negative root 3 over 2. All right, so there is our unit circle. Again, this is review of pre-calculus stuff. It's something that does take practice, but with practice you get it. And I would encourage you to do flashcards or just practice writing this thing out until it's super comfortable, because we're going to be using trigonometry a decent amount. Now, how do we use this thing? Well, I'm not going to go too much into the definitions of the different trig functions, but what we need to be aware of is that we have x and y coordinates all the way around the circle. And the x, and again, this comes from the definition of what these trig functions are, is going to be the cosine of the angle, and the y is going to be the sine of the angle. Okay, and we have to make sure that we get the proper plus or minus depending on which quadrants we're in, right? You might well, yeah, let's see where that takes us. Before we actually evaluate these trig functions, let's make sure that we have some basic identities together. And so these identities, again, they're from pre-calculus, and we're going to use them a lot this semester, so we just have to have them wired. The first 6 are reciprocal identities. Cosecant of an angle is equal to 1 over sine of that angle. Secant of an angle is equal to 1 over the cosine of that angle. And cotangent of theta is equal to 1 over the tangent of theta. And then to the right here, you have all the same ones, just written a little differently, right? So here we have secant, and here we have cotangent. And then from there, we have the ratio identities. Tangent of theta is sine over cosine, and cotangent is cosine over sine. Now, there are a couple other really important identities. I'm not going to go into them in a lot of detail right now because we don't need them, but I have to mention them because along with knowing these, 8 identities here, you also absolutely need to have your Pythagorean identities memorized. Now, the basic Pythagorean identity is you basically take cosine theta, which is your x, and square it, and you add it to your sine theta and square that, and that's basically your y squared equals to 1. And the reason this happens is because we're on the unit circle. So no matter where we go here, let's take some odd color. No matter where we go on our unit circle, we have a right triangle like this, right? And so if we take x and square it, and we add y and square it, we're going to get 1 squared by the Pythagorean theorem. So in other words, cosine, which is the x, squared plus sine, which is the y, squared, is going to equal the hypotenuse squared. So that's all we're getting at there. Okay. Now, from there, we need to start evaluating these things. So we need to be real fluid in being able to find the sine, cosine, tangent, secant, cosecant, and cotangent of any of these special angles around the circle. If we encounter a problem that does not involve these special angles and we're trying to evaluate trig functions, in most cases we'll just throw that into a calculator. But we need to be able to do these all the way around the circle. So again, the way this works is we have an x and y around the circle, which is going to be cosine for x and sine for y. So with this very first problem, part A, we're noticing that we're dealing with pi over 4. We have to find that in our unit circle right there, pi over 4. And because it's sine, we want the y value. And so the first one is going to be the square root of 2 over 2. Moving on to the next one, we want the cosine of 2 pi over 3. So 2 pi over 3 is right here, and the cosine is the x value. So that will equal -1/2. Moving on, next one we have the sine of 3 pi over 2. That's going to be down here, and the sine is the y value. So we get -1. Next, we're looking at the cosine of pi. Pi is right there. And we're dealing with the x value, which is going to be -1. Now, I did those pretty quickly. If you need to, pause and rewatch what I did. But the only reason I'm able to do these fast is because I know, just from experience, where all these angles lie on the circle, okay? The more you do it, the easier it gets, is really what it comes down to. Moving on, we want to look at the tangent of 5 pi over 6. And the thing to remember, the tangent of an angle, in this case 5 pi over 6, is equal to the sine of that angle over the cosine of that angle, right? That was the ratio identity. So all we need to do is go to 5 pi over 6, which is right here. We're going to take the sine, which is the y value, right? Which is that right there, which is 1/2. And the cosine, which is -√3 over 2, and form this fraction. Once we have that, we're going to multiply top and bottom by 2 in order to clear the compound fractions, and we end up with this guy. Maybe rationalize this now, multiply by √3 and √3, and we get the square root of 3 over 3, and that's negative. And just like that, we found the tangent, -√3 over 3. So it's a little bit more work to find tangent, cotangent, and as we'll see, secant and cosecant in a moment, but that's the approach we're going to take. So next, cotangent of pi over 3. So go ahead and find pi over 3 on your unit circle. Looks like it's right there. We're going to remember that the cotangent of pi over 3 is equal to the cosine of pi over 3 over the sine of pi over 3. And so the cosine of pi over 3 is the x, so that's 1/2. The sine of pi over 3 is √3 over 2. Again, let's multiply top and bottom by 2 to get 1 over √3, and then we'll rationalize again, kind of similar to the last one, and there's our answer. Okay, let's look at tangent of 5 pi over 4. So 5 pi over 4 is right here. Look at our x and our y. Tangent is sine over cosine, and they're the same value. So a -√2 over 2 over a -√2 over 2 will give us a +1. Next is the secant of pi over 6, which is 1 over the cosine of pi over 6 from our work above, right? That was when we were looking at the reciprocal identities. So pi over 6 is right here. And the cosine of pi over 6 is the x value. So we've got 1 over √3 over 2. And again, I'm going to get rid of the fraction in the denominator by multiplying both top and bottom by 2. So I get 2 over √3. And if we rationalize, we're going to get 2 root 3 over 3. And there is the secant 2 root 3 over 3. Another way to do it is just find the cosine and then flip it, right? This right here is the reciprocal of the cosine. So that's maybe a quicker way to go. Looking at one more, 3 pi over 2 is down here. We want cosecant, right? So cosecant of 3 pi over 2 is 1 over the sine of 3 pi over 2. The sine of 3 pi over 2 is this y value right here. And we just need to take the reciprocal of that to get the cosecant. And that, of course, the reciprocal of -1 is -1. So that's how we do this using the unit circle. Just a couple quick comments. Comment number 1, are there other ways of evaluating these trig functions? Yes, there are. When I was learning this, I did everything with right triangles and the basic sine and cosine curves. If you want to see how to do that, come talk to me. I'll show you, and you can choose to do it that way. Most students choose the unit circle. What else? If this whole thing went by super fast and you need more review than this, come talk to me after class, come to office hours, and we can go through this in a lot more detail. Your job now is to go ahead and do the rest of these using the unit circle or whatever method you're comfortable with, and get as much practice as possible. So there you go.